Good afternoon. I'm Hirono Emily. Today I will discuss about question 5a from Mark 3. The manager of a factory claims that the average weekly loss of man-hours due to accidents after the implementation of an industrial safety program is not more than 20. A random sample of 30 weeks is selected after the implementation of the program, and the mean and standard deviation of weekly loss of man-hours due to accidents are 27 and 6 respectively. Test for the manager's claim at 1% level of significance. According to the question, we can see that the null hypothesis is mu equal to 20, and the alternative hypothesis is mu smaller than 20. Since the sample size is big enough, which is 30, by the central limit theorem, the sampling distribution of mean is approximately normal. From the alternative hypothesis, one-tailed test should be used. The standard score of 0.01 equal to 2.33, and the critical region will be z smaller than negative 2.33. In order to find the test statistic, the formula of mean minus mu over standard deviation over square root sample size will be used. So we have the answer of 27 minus 20 over 6 over square root 30, and the result will be 6.390096504. Since 6.390096504 is bigger than negative 2.33, and it is not in the critical region, so null hypothesis is not rejected. As a result, the hypothesis that mu equal to 20 isn't rejected at a 0.01 level of significance.
Hello everyone, I am Dong Xiaolin Mini from XHTM. Today I'm going to talk about mock paper 3, questions 5b. First, I let mu1 and mu2 be the mean of commercial district A and B respectively. Then we can start the 7 steps of testing hypothesis. The first step is null hypothesis equal to mu1 minus mu2 equal to 0. The second step is that since mu1 less than mu2, while the H1 is the hypothesis against null hypothesis, therefore H1 equal to mu1 minus mu2 larger than 0. The first step is level of significance equal to 0.01. The fourth step is, since the sample size larger than 30 and the sample SD is known, therefore t-test should be used and it's one-tailed test. Then we can calculate the degree of freedom by adding up the number of sample size of 2 samples, which is 13 plus 16 minus 2, and then we get 27. Then we can refer to the t-distribution table. T alpha equal to t 0.01 equal to 2.473, so that we can know the critical region t larger than 2.473, just like the graph here. Then we can testing the statistic, and then we have to find out SP by this equation, and then we sub all the numbers into the equation, and we get the answer 736.21, and then we find T by this equation, and then we get the answer of negative 0.8686. For the sixth step, since negative 0.8686 smaller than 2.473 and is not in the critical region, so H0 is not rejected. So null hypothesis is not rejected. Finally is the seventh step. Therefore, the hypothesis that the mean concentration of suspended particles in district A is less than that in district B is not rejected at 0.01 level of significance. Thank you.
I am Milu and I am going to explain Mock 4 question 4C. This question is in order to test whether a special training programming is effective in increasing the sales made by the salesman of a large printing company. The following data are collected concerning the weekly sales in $1,000 of 10 randomly selected salesmen both before and after attending the training program. Assuming the population are normally distributed, is the programming effective at 2.5% level of significance? We first let D be the difference between the weekly sales before and after of the randomly selected salesmen attending the training programming. We set the null hypothesis as mu D equals to 0 and the alternative hypothesis as mu D is greater than 0. And we know alpha is equal to 0.025 according to a level of significance. Since we assume the population is normally distributed, the sample can be paired. And since the sample size is small, both N1 and N2 is less than 30, a one-tail paired mean different t-test should be used. This is the test statistics we're going to be using. And we know V equals to N minus 1, so which equals to 9. And we already know that alpha equals to 0.025. So t value at alpha and V is equal to 2.262. The critical region will equal to t when t is greater than t at alpha and v. Then we find the mean difference, which is equal to 0.64, and the standard deviation is equal to 1.8620. Then we apply all the numbers into this test statistics and we'll get the answer of 1.0869. And since the t-value is not greater than the critical region, we cannot reject the null hypothesis. So in this case, the training programming is not effective.
I'm Carol and today I'm going to explain Mock 4 question 5a. It is claimed that the mean daily expenses per tourist in Hong Kong is at least 2,000 Hong Kong dollars. To test this claim, a random sample of 100 tourists is interviewed. Would you agree with this claim if the sample shows a mean daily expenses of 1,850 Hong Kong dollars with a standard deviation of 500 Hong Kong dollars? Use 1% level of significance. Since it is claimed that the mean daily expenses per tourist in Hong Kong is at least $2,000, we have the null hypothesis H0, mu equals to $2,000, and we have the alternative hypothesis H1, mu is smaller than $2,000. And since we use 1% level of significance, alpha is equal to 0.01. From the question, we can see that the sample size is 100. As the sample size is 100, which is larger than 30, and we can use S to estimate standard deviation, z-test is used. And from H1, it is a one-tailed test. From the normal distribution table, we can find the value of Z, which is 2.33. And therefore the critical region is Z is smaller than negative 2.33. To find the value of the test statistic, we can substitute the numbers into the formula. In this question, Z equals to 1,850 minus 2,000 over 500 over the square root of 100, and it is equals to minus 3. Since negative 3 is smaller than negative 2.33, it is in the critical region, and therefore H0 is rejected. and therefore the claim is rejected at a 0.01 level of significance.